what the funk are functions. So we're talking about math tools right now, and I'd like to take a minute to step back from the physics side of things and kind of go to closer to a math world. Okay, what are functions? Now, in your math classes, in theory, you've been for years looking at equations like y equals mx plus b, right? And you're like, oh, like that's a linear function. Or sometimes maybe you don't write the word y. Maybe you write the word f of x, okay? Because that means y, which we could say equals like mx plus b, or maybe it equals x squared or x cubed or whatever, right? But what exactly is a function? A lot of times when math classes describe a function, what they're describing is you put something in and you get something out, which in terms of like numbers, that's kind of a weird thing to think about. So let's kind of think of it in a more real world scenario here. So let's just do this real quick, okay? Because this is kind of like a graph. And we'll call the bottom of the graph here what we're putting into the function, and this is what we're getting out of the function, okay? And these we would know as being our x and our y axes. Now, in terms of in and out, let's think about this. In a little bit of time, arguably the greatest kid holiday to ever be created will come about, Halloween, where we all dress up and we run around to our neighbors and we ask them for candy, and somehow we've tricked all the adults and all the homeowners into just giving away copious amounts of sugar to children, okay? Terrible idea for a number of reasons, but we've done it. And I love this because I love candy. I love all the different kinds of candy. I love the sugary stuff. I love the stuff that's sweet. I love the stuff that's sour, like candy, candy, candy. So whenever it's Halloween in my neighborhood, I dress up so nobody can see how old I am and not give me candy, and I just book it because I've got longer legs than all the little children running around, so I can get more houses and more candy. And I set up wheelbarrows that I can dump candy into like the night before, and I can like retrieve it later on. So I get pounds and pounds and pounds of free candy, and it is what I live for, okay? The entire year is just dedicated to one night, Halloween. Now, if we think about when I get home from Halloween, I've got a ton of candy and I can't help myself. I have to start eating it, okay? I have to. I love candy that much. So what I start doing is I start eating this candy, and this candy is literally going into my body, okay? I am consuming more and more and more and more candy. But if you've ever experienced this compulsive drive to continue to eat candy, you know what's going to happen in a little bit. I'm going to eat so much candy that I'm going to start vomiting. I'm going to start vomiting everywhere, okay? This is what's coming out of me. This is vomit. It is not pleasant, but it is worth it for the candy. Now the issue is that, and let's just kind of draw a y equals mx plus b graph here, okay? The issue with this is if we look at this y equals mx plus b, when I don't eat any candy, when it's at 0 for the origin, when I don't eat any candy, I will not vomit. But as soon as I ingest a little bit of candy, I am already going to vomit a little bit. Because if I go up and I strike my candy graph, I can see that over here, I am at some level of vomit. Where this is some, let's call this like 1 and this is 2. This would have an ordered pair of 1 comma 2 here, x comma y, of candy comma vomit. So as I eat candy, I vomit. As I eat more candy, I vomit more. Okay? I know that's disgusting to think about, but it's the truth and it's a fact. And as I eat more and more candy, I will vomit more and more and more and more. Okay? I'm inputting something into my body, the candy, and I'm getting an output from it, which is a vomit. This is a function. When we talk about a function, what we're saying is some function, which is f, is dependent on some inputted value. This normally lies on the x-axis, so we call it f of x. That's the input. Specifically, in our example, we could say that this is like f of, and this would be candy. Okay? So our function is dependent on candy. The reason why we say this is equal to y or a y-axis is because this y-axis is the output. So whenever we say that we have something like f of x here, which is the f of candy, what we're really saying is f of x is equal to an output. A function of our input is the output. As I consume on some function the candy, it will equal how much vomit I have. So the function of candy equals vomit. Okay? So this is a function. That is what is going on. Literally think of it as something is going in, something is coming out. Now in mathematics, this function, and the blue line I drew here is y equals mx plus b. That is a linear function. We know this b here is like a y-intercept. It would be 0 in our case. But if I changed our function a little bit, let's say I drew it up like this. This would be a little weird because if I didn't eat candy, there's 0 candy being eaten right here, I'm still vomiting. I'm still vomiting when I don't eat candy. I'm just always throwing up. That's terrible. Or I could change it so that the intercept could be negative, and maybe it's down here, right? So maybe in this case, I can eat candy, and until I get to this point, I won't vomit. But as soon as I get beyond this point, now I will. This is probably more akin to a real life scenario here. Or maybe this is going to be like an x squared, where it's going to, kind of up like that, right? Kind of a parabolic curve. So we have many functions that can describe things. It's just a matter of something has to go into them and something is coming out. And traditionally, these are just numbers that we're talking about. But if we think about them in terms of our graphs, we do have our x and y axes of what's going on here, okay? Now, something else that pops up in mathematics is what's known as an inverse function. You may have talked about writing something like f to the minus 1 of x, okay? And that's not the negative first power. This is an inverse function. What this is representing here, and oftentimes whenever you do this in mathematics, you swap your x's and y's position in order to find this. What they're basically saying here is instead of knowing how much candy I'm eating to figure out how much I'm going to vomit, we're going to do it backwards. We're going to leave the amount of candy as a mystery, but we're just going to watch me vomit. We're just going to watch me throw up all over the place. And based off of how much I threw up, we can say how much candy we have. So we just went backwards with it. That is all an inverse function is doing. It's saying, hey, look, I know how much vomit you have here, and that means you had to eat that much candy. Okay, it's just the backwards way of thinking about it. That's what an inverse function is. So I know a lot of times people get confused about these inverse functions. They're unsure of what they mean, but just think about it as the original function that you have, but you're just now playing the game backwards. Okay, and that's all these functions are. They're really just looking at things on an XY graph, these axes here, and then this function is just describing what is in and what is out, and kind of what curves do we have. And we're going to be looking at a lot of these graphs and interpreting these graphs for their physical meanings, such as, are you always vomiting, or do you have to eat a lot to vomit? Are you increasing your vomit for like an x squared? These interpretations of the graphs have large meanings in physics because we actually have physical things like the candy and vomit here. And these functions that we choose will be important as well. So that's what we're talking about. We're talking about generic functions here. In later videos, we'll talk about how we can use equations to think about functions. We'll start thinking more about the units that we put on our x and y axis and graphing things appropriately. But I just wanted to talk now about the functions themselves and what's going on. And really, I know this was a super gross example, thinking about me all throwing up everywhere. And hopefully you're not throwing up on the other side of the computer. But it really works to think about it. Like you eat something, and then if you eat too much, you throw it up. Okay? So hopefully that helped you out in the idea of functions and inverse functions. If you still got questions on things, contact me, let me know in class. But for right now, this is finished. Take it easy. Eat as much candy as you want.